Well, we are at facility number 2 here, part of Dart Machinery, and this is the place where after the casting is done, this is the place where the blocks come, whether they're aluminum, whether they're cast, steel, whatever the case might be. The cylinder heads are here. The intake manifolds are here. Why? Well, all the CNC equipment is here. You can take a look right up there at a raw block. It's just waiting for its rotation to go around and it make its way through the process of, first of all, boring its cylinders and all the things that go along with being part of a Dart Machinery block. Now, Jimmy, if you can do this while you're backing up, it's kind of hard to do. But here is a pallet and a skid full of blocks. Now, each one of these things will come with a folder. That folder will have all the configurations, all the numbers that particular customer may want for that particular case or that occasion on his particular block. Same thing for the cylinder heads. Same thing for the intake manifolds. Each and every one of them has a number. And believe it or not, in talking just a little bit ago with Mike, this place has produced over 28,000 big blocks, steel big blocks, cast all the way through the machining process that's out there today. Just kind of giving you a heads up here of building number 2, facility number 2. A lot of buildings, but this is the machine shop, if you will, for Dart Machinery right here. And by the way, you know, you might walk into Dart Machinery building number 2, 3, 4, 5, or 6. You just never know who you might run into. Mike, who is the guy who is the partner with Dick Maskins, and the guy who runs this particular building, he's got some pretty cool spectators with him today. I see Tommy Franklin over there and the one and only Pat Musi in the house as well. Yeah, it's a very interesting day here at Dart Machinery. Who'd have thought that? We'll continue to make our way around. CNC, automated equipment everywhere. The A77 model, not one of the newer models, but one that is very effective. Why? Well, you take a look at that fixture up there right now, as it looks like we're doing small block Chevrolet heads. I'll pipe in here, listen to Mike while he's chatting away here.
Same principle as on the heads. We try and handle them as little as possible so the stack error, the machining tolerances are held by the machine, not the operators. So as the casting goes into the machine, the raw casting, you can see sitting on the pallet, gets loaded to the tombstone. The tombstone now will do the valve cover and the exhaust. And then it'll be moved to another station. We'll do the deck and the intake. The top station will do the spark plugs, the end pads. So the head's handled 3 times. You get a finished head. Right now we have 2 operations done on this machine. The pallet that's on the inside is a 5-axis and is doing all the special work on the forward block, the deck, the bores, the lifters, the mains, the freeze plugs, and anything else that's motor mounts. Then when it cycles out, we put the main caps on our bench right behind me, and then it goes back in the machine on the deck, and this will finish the cam, finish the crank, finish the bell housing dowels, and the front cover. And then the block is finished. We're going to have our leader stop what it's doing inside the machine. He's going to cycle it out so you can see how these machines actually work. They never stop running. They run 24 hours a day, and as long as we keep loading parts on it, they keep running.
24/7. I mean, is that 306? 24/6.
24/6. We don't work Sundays.
Continuing on, we come into the billet part of the shop here, and give me an idea what we're looking at right here.
Well, these are a Ford small block billet. They've water jacketed. They've got a welded plates. It's been heat treated. Now we're ready for final operation. 2 of them are in the as raw position before we touch them. The other one you're looking at is done through op number 2. It's still waiting for the cam and crank to be done. You can see the bores are done, the lifters are done, the head bolts, everything in the vertical position is finished. Your oil feeds, your motor mounts, there's virtually nothing else to do to it.
Looks like it's been lightened up pretty much. I mean, it looks like you got as light as you could. Also, obviously, since it's aluminum, it'll accept sleeves as well there.
Yeah, this is a dry block, what you call dry, and it's made for a traditional style aluminum block with dry sleeves. Now, there is some more machining to do on it, so if anybody looks at it, they say it's not done, that's because we're still waiting for our final operation.
So let me ask you a question. Cubic inch wise, what does that thing ultimately end up making, or what's the variables with sleeves there?
It's your bore size and your crank, but traditionally these blocks go out to 440 cubic inches as a small block.
So primarily a drag racing motor specifically, or no?
We've made lots of these for the circle track racers.
You say dry block, that's kind of the only reason I asked the question.
The sleeves are dry, but there is a water jacket around the block.
I got you. Okay, cool. That part of the aluminum part of the program, I got to tell you what, man, this whole plant is just unbelievable. How many years did it take you to amass all this equipment and everything we've got put together here today?
We bought our first machine here for Dart in 1995.
Yeah.
And since 95 to now, we've got, I think, 31 machines total.
And like you said, they run, tell me the hours again.
We run 24 hours a day, 6 days a week.
Okay, back in the guide room, guide tooling room.
Yeah. The bars we buy from a supplier. Obviously, material, we'd rather keep that to ourselves, both bronze, brass, and steel. And in this machine at the moment, it's not running, but it makes a guide, starts with a bar and comes out like this.
Wow, how about that?
Every single guide is inspected to make sure it's within our tolerance.
So it's cut and threaded there, and it's obviously a guide meant to go, you know what, I didn't even know. I just finally realized that.
It's ready to install in a head.
Ready to go in there, just like that.
We make two different styles. One that's finished, so you could put them in a finished head and put your valves in. Or for our heads that we're machining ourselves, we install it and then we finish the guide on the machine.
In a continuation of following all their own quality control, everything's made here. We just got to see the valve guides. Now check it out. Main caps and caps in general start from the raw and take us from there.
This is a raw burnout that we have purchased here in the Detroit area. It's flame cut, it's stress relieved. We grind it ourselves in the other part of the building. Then it goes in on these machining centers. Starts as this, comes out like this. So this is a cap ready to bolt on the rear of a big block Chevrolet. There's a lot of work to making caps, making blocks, and still producing it where everybody can consistently have the best product we can make. One area we haven't talked about is our inspection in our tool room. We're going to go visit that next, and I believe that's what really separates Dart from, I would say, 95% of our competition.
Well, again, as we mentioned earlier, the key to everything here is that everything's done in-house. The finality to this thing, though, is the tooling and the quality inspection area.
Correct. Now, what we have here is an infrared camera and a presetter built in. So our leaders, when they want to check tools, they want to make sure the sizing is correct. Not only can they look at the tolerancing and the location, they can also view the cutting edge of the tool. I'm going to have my friend here, Josh, he's going to show you how accurate we can look at our cutting edge of the tools. And that's very, very important as far as we're concerned. So you want to demonstrate?
Sure, no problem. Now with this one right here, we can get the height offset, and we program the number from here directly into our machine. So then our work offsets know from the machine where the tool is going to be at and how to cut on the product.
Gotcha.
The diameter, if we need to change the diameters of bores, then we can do that by this machine also. This is a good insert. You see all the sides are good. You can tell the quality, no wear. It's a newer insert. I have an older one on the other side. On here you can really see how it's chipped down and broke down.
Yeah, there's your cutting edge, how it's starting to deteriorate from the chips. As the tool's cutting, it's creating chips and heat. And you can see it with our camera, what it's really doing. Now, when he indexes it back to the other cutting edge, which I had him for demonstration purposes, you won't see that imperfection. There's a brand new insert.
So those things, when they get to the point of the one that's on this side right here, is that trash, or is that something you take to the machine room and refile it again?
It's trash. You take it and
done.
throw it away.
Throw it right in the trash can.
Right. Yep, usually
Recycle some of it.
Yeah.
recycle. The machine itself will have a life monitor. Generally, we know approximately how long these should run. Like this one, 45 minutes. So the machine will let us know when the 45 minutes is up. Then we come, bring it in here. Of course, some last better than others. We can get a little bit longer out of it. So
Depending on heat and that type of thing.
exactly. So that might actually help us save money and run a little bit longer on the insert than we typically would. Or if we see a problem, we can pull it out earlier. And it helps us keep the cylinders a lot better, obviously, with now starting to oval out because of tooling going bad.
Wow. Jimmy, it continues to get better and better as we make our way in here into the QC department. I think we've actually got a cylinder head mocked up down there now. And I want to say this so bad because they say it on how it's made. How they say it all the time? A worker, what's his actual name? That's Sean. As Sean gets things set up here in the program, I must tell you, in my days of many, many years ago, I worked for the Square D Company, and we had measuring devices that were very similar in nature to that right there. And those things are works of art, and they're not very cheap to have around the house either, are they?
Now, this machine has really paid for itself for many reasons. The biggest one is quality 24 hours a day. When you work one shift, it's real easy to monitor everything that's going on. But as a 24-hour shop, 6 days a week, you never know when a machine's going to break a tool's going to blow up, part casting is going to be bad, you're going to get some sand in the casting, you're going to have an operator that has done a oops, and that does happen. It happens everywhere. This machine really allows us to make sure, one, that the machine, once it's been set back in production, it's correct. Two, we can go back and find out what happened on the other blocks to see if they need repair or if they're okay to ship. So it gives us lots and lots of answers that would be very difficult without this style of equipment.
Very cool. And Jimmy, another thing I want to add is, obviously you can't check every intake, every cylinder head, every engine. So through the course of a working day, it's one of just about everything that is in production for that course of the working day will make its way into this room for Sean or whomever happens to be running the equipment that day for the quality control inspection process. You're looking for cylinder heads, intake manifolds, blocks? It happens right here in Michigan, ladies and gentlemen, Dart Machinery. Thanks for being with us on PDRA TV. You've been watching a PDRA TV in-house production.